Hello, good day. How are you? Oh, I'm glad that you're doing great. By the way, my name is Sir Joseph Alsacolias, your math teacher for today. This will be the 8th week of the second quarter. And let's give some credits to Sir Arnold Kapanian because he is the one who created this presentation. Thank you very much, sir. Okay, so in our most essential learning competencies, solves equations involving radical expressions and solves problems involving radicals. In our objectives, the student should be able to determine radical equations, solve a radical equation, identify extraneous solution, and solve word problems involving radical equation. Are you ready? Okay, in our review, let's have a jolt activity. So all you have to do is to rearrange the jumbled letters. Okay, so the first jumbled letters is this. What word is this? It's a radical equation. Very good. What is that word? A radical equation is an equation whose unknown quantity is in the radicand. Below are examples of radical equations and not radical equations. So here, radical equations. As you can see, we have 3 square root of x plus 5 equals 20. And then square root of 2x minus 3 equals x plus 2. Some variable x are found in the radicand or inside the radical sign. And as you can see, we have the equal sign to make them equation. And the following are not radical equations where the variable is not in the radical sign or is not inside the radical sign. It should be inside. In our example, x square root of 3 plus 5 equals 20. As you can see, the x here is outside the radical equation. So in order for it to be radical equation, it should be inside the radical sign. Understood? Okay, so let's proceed to our lesson. In this lesson, you have to solve radical equations. Hence, you have to assume that if two numbers are equal, then the square, cube, or nth power are also equal. So, if x equals y, then x raised to n equals y raised to n. Or if nth root of x equals y, then the nth root of x raised to n equals y raised to n. And x is equal to y raised to n. Okay, in solving radical equations, you have to follow the following steps. 1. Write the equation such that the radical containing the unknown is on one side of the equation. Number 2. Combine similar terms. Number 3. Raise both sides of the equation to a power same as the index of the radical. The equation should be free of radical to complete the solution. And then the last step, check if the value or values obtained will make the original equation true. Okay, let's get to it. We have the first example. Square root of x equals 7. Is it a radical equation? Let's look into the radical sign. Is there an x in the radical sign? Yes, so therefore it is a radical equation. So what are we gonna do? In our principle or theorem, that what we have tackled on the previous slide, if square root of x equals y, then, the nth root of x equals y, then nth root of n raised to n equals y raised to n. So as you can see here, the index is 2 because it doesn't have a number. It is automatically 2, right? So, we need to power them up by 2 as this radical is 2. Square root. So we need to square both sides. So the square root of x squared equals 7 squared. And then the root of the square root, the square of the square root is just x. Okay, so simply saying, we just have to convert this to further understand what is going on. So I transform this from radical equations to radical expression. To rational expression. So square root of x is x raised to 1/2, and then I multiplied by 2 because it's power of a power rule, right? So 1/2 times 2 is equal to 2 over 2, and that will make it 1. Okay? And then x raised to 1 will be x. Okay? And then 7 squared, 7 times 7 is equal to 49. It's not 7 times 2, okay? 7 times 7. So the value of x should be 49 to make this equation true. Now let's check. So the answer earlier is 49. So I'll let x be 49. So the square root of 49 is 7. So 7 equals 7. So therefore our answer is correct. Let's go to the second problem. The cube root of x minus 6 equals 3. What is our index? It's 3, right? So we need to power them up by 3. Okay? So the cube root of x minus 6 raised to 3 equals 3 raised to 3. And then cube root of something and then raised to 3 will be our radicand. So x minus 6. And then 3 cubed, or 3 times 3 times 3, will become 27. Okay? So we need to find the value of this x. So what are we going to do with the minus 6? What integer should we add to make this negative 6 0? We need to add it by positive 6, right? So we need to add more 6. So x minus 6 plus 6 equals 27 plus 6. We need to add 6 to both sides to maintain the equality. And that is called additive property of addition. Okay? So negative 6 plus 6 will become 0. So x plus 0 will be x. And then 27 plus 6 will become 33. So the answer is 33. Now, let's check. So the x is 33. So I substituted 33 to this x. So that would be 33 minus 6. And 33 minus 6 is 27. And we all know that the cube root of 27 is 3. Because 3 times 3 times 3. Okay? And that would suffice. Let's go to the next problem. 4 plus square root of x minus 2 equals x. Okay? So we need to remove this because we're going to remove this. But we need to remove 4 first because it's easier. Okay? So what are we going to do to make this 4 0? We need to add negative 4, right? So we need to subtract 4 to both sides. So 4 minus 4, then plus square root of x minus 2, and then x minus 4. Okay? And then 4 minus 4 will be 0, and that would be eliminated. So what is left on this side is square root of x minus 2. And then x minus 4 will be as is. Okay? So, what are we going to do to remove this? We need to power them up by 2 because the index here is 2. So square root of x minus 2 squared, and then the square of this, x minus 4 squared. Okay? And then the square root of this is the radicand. So x minus 2 and then x minus 4 squared. So we need to, the square of the difference of two binomials. Okay? So I used FOIL method here, so you all know what to do. So the answer should be x squared minus 8x plus 16. Okay? And after that, I need to remove this x and negative 2 from this side. I will make it 0 to get the factor of this. Okay? So this is positive x, so I need to subtract x to both sides. And I also need to add 2 to both sides, okay, to remove this x minus 2. So x minus 2 minus x, so x minus x will be 0, and then negative 2 plus 2 will be 0 as well. and then I need to do to another side, so negative x plus 2. So this side will be 0, and then x squared doesn't have like terms, so I will write x squared, and then negative 8x and negative x are like terms, so I need to add them. So negative 8 plus 1, invisible 1, here will be negative 9x, and then 16 plus 2 is 18. So what we get is x squared minus 19x plus 18. So I factor out this. So the factor of x squared minus 9x plus 18 is x minus 6 and then x minus 3. So if I take this separately, so the first value of x might be 6 and the second value of x might be 3. So 6 and 3 are both accepted because they are both correct. Okay? Let's check if those values are correct. Let's check. So this is our equation last time. So I substituted the first value, which is 6. So x will be 6, and then x here will be 6, and then the other side is 3 and then 3. Okay, I subtract this. 6 minus 2 will be 4, and then here 3 minus 2 will be 1, and then square root of 4 is 2, and then the square root of 1 is positive negative 1. Yes. Okay, so your answer might be negative 1 because when you multiply negative 1 by itself 2 times, it will be positive 1. So the square root of 1 will be positive 1 and negative 1. This applies to every positive integer. Okay, so when you get the root of a positive integer, your answer will always be positive and a negative. Okay, so in this matter, we are going to get the negative 1. Okay, because 4 minus 1 is equal to 3, and then 4 plus 2 is equal to 6. So these are both correct. Okay, and that would suffice. Okay, let's have a word problem. A man walks 8 meters to the east, then turn south and walk 6 meters. The problem is, how far is he from his starting point? So what is our starting point? Here. So we're going to measure how far he is from his starting point. So here he is right now. So this is what we are going to measure, the length of this. So what shape do you think it formed? It's a triangle, right? So we can use Pythagorean theorem because it is a right triangle. Okay, so the formula for Pythagorean theorem is 6 squared equals a squared plus b squared, and I let 8 meters be the first side or the a, so the second side will be b, and then the c is the hypotenuse. Okay, so if I take this away, I need to square both sides, so that would be square root of a squared plus b squared. So I let the value of a and b be those numbers. Okay, so c will become the square root of the square of a, which is 8, so 8 meters squared, and then the square of the b, which is 6 meters. And 8 meters squared is 64 meters squared, and 6 meters squared is 36 meters squared. And I add them, so the answer is 100 meters square, and I take the square root of that, so the answer is 10 meters. So therefore, the length from the starting point to his location right now is 10 meters. Okay, another problem. A ladder 12 feet tall leans against the wall of the building. The ladder touches a point of the wall 8 feet from the ground. How far is the foot of the ladder from the building? Okay, so this is the ladder, 12 feet tall, and it leans against the wall of the building. So this is the building. The ladder touches a point of the wall 8 feet from the ground. So from this ladder to the ground measures 8 feet. Okay, and then the problem tells us how far the foot of the ladder is from the building. So from this building to the ladder. Okay, so I let this wall be the h or the height of the wall, 8 feet, and then the hypotenuse or the ladder that leans against the wall is 12 feet, and then I let this measurement be d because it stands for distance. Okay, so this will also be in the Pythagorean theorem because it is a right triangle. Okay, so L squared, because this is the hypotenuse, L squared is equal to h squared plus d squared. So since we're looking for this, this d should be alone. Okay, so I need to transfer this h squared to another side. So d squared will become L squared minus h squared. Okay, and I remove these two, so I need to extract both sides. So d is equal to square root of the square of L minus the square of h. So I substituted all the variables. So the L is 12 feet and then the h is 8 feet. So 12 feet and then squared is 144 feet squared, and then 8 feet squared is 64 feet squared. I subtract them. So the answer is 80 feet squared. So I need to simplify this. So find a factor of 80 that is a perfect square. Okay, so 80 is 16 times 5, and then the square root of 16 is 4. So the answer is 4 square root of 5. Therefore, the measurement of this is 4 square root of 5 feet. Okay, and that is approximately 8.9 feet. Okay, let's go to another example. The area of a square lot is 162 meters squared. How long is the side of the square? Okay, so this is our visual representation. So the area is 162 meters squared, and then what is asked is the length of the side of the square. Okay, we all know that the area of the square is the square of the sides. Okay, so I did this because of the commutative property. So s squared is equal to a, and then we all know that the area is 162 meters squared, and I extract that because I just only have to find the value of s. So s will be the square root of 162 meters squared, and simplify this number. So 162 is 81 times 2. Okay, and then 81 is a perfect square, so 81 square root of 81 is 9. So the answer is 9 square root of 2. Okay, the last example in a word problem. The diagonal of the triangle is 5 square root of x. If the width of the triangle is x and the length is twice as I'm sorry. If the width of the triangle is x and the length is twice the width, what is the dimension of the rectangle? Okay, so what it says here is the diagonal is 5 square root of x, and this is the diagonal. Okay, and then the width, which is here, of the rectangle is x, so I'll let this side be a, and a is equal to x, and the length is twice as width, so this would be multiplied by 2, so that would be 2x, and I'll let this length be b. And the question is, what is the dimension of the rectangle? So we need to find the exact measurement of each given sides. Okay, the first side, the second side, and this diagonal. Okay, so we just have to find the x first, and then we need to evaluate this expression to get the exact value. Okay, so as you can see here, we formed a right triangle, so Pythagorean theorem is also used here. Yeah, so the hypotenuse or the c will be the longest sides, which is 5 square root of x, and then the first side is x, and then the second side is 2x. Those are all squared, so the square of 5 square root of x equals the square of x plus the square of 2x. So 5 square root of x is 25x, because 5 squared is 25, and then square root of x will be just x, and then x squared is x squared, and then 2x squared is 2 squared 4, and then x squared squared. Okay, and then because these are like terms, I add them, so that would be 5x squared, and then I divide both sides by 5x. Okay, so 5x 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 5x. So what is left here? X divided by x is nothing, and then 25 divided by 5 is 5, and then 5 divided by 5 is 1, and then x squared divided by x will be just x. So what is left here is 1x, or x. So the value of x is 5. Okay, so the main question is, what is the dimension of the rectangle? So we need to evaluate this equation. Okay, in our first side, the measurement of the first side is 5 because it's just x. Okay, and then the second side we just have to multiply 5 by 2, and that will become 10. And then the third side we just have to substitute x to 5, so that will be 5 squared to 5. Okay, so those are the answers. Okay, in our expected outputs, you have the following to submit. We have the learning tasks, performance tasks, journal, and the summative test. So this is our learning task, and this will be our performance task, and this is our reflective journal, and this is our summative assessment. Should you have any questions or clarifications, don't hesitate to ask your subject teachers. That would be all, and thank you. I solemnly swear I am up to no good. Thank you.